More people. Candace. All right, guys, so today's really all about you. I didn't bring anything besides putting the formula sheet together. So let's do that, and then I'll open it up to whatever you want to focus on. Nope. I brought some copies, but they're all gone. But I can print one out in my office. You can get it off your email. Either way, yeah. So what's this test covering?
Chapter 8 and 9.
Yeah, so confidence intervals and hypothesis tests. So confidence intervals, there's 5 equations. There's 2 for... 2. It's like somebody wants to come in. It's not going to work. There's that one for the mean. What's the other one going to be?
P.
So that's going to be here. What's this one going to be?
T.
The one that needs t-scores. And of course I need t-scores when I only know S. Good. So don't forget, there's a note on your formula sheet that I must let you have. When do I use t-scores, Jeff? Well, probably when you only know S, because that's the formula it's in. Right? So that's why they were invented, to cover our ass from when we don't know the real standard deviation, we have to use an approximation. That's why they were invented. But you got it sitting there on your formula sheet. That's the note. Z-scores go with this. Z-scores go with that. But what's got to be true also to use either one?
Normal.
You have to be working with a normal distribution. Normal distribution. And then this guy, you always use Z-scores as long as it's normal. Yes?
Because you said that, it was just a question about the quiz. So if you were answering the question about the T or Z scores, you would have to add that you also need to know it's normal.
Yeah, and on that quiz, I didn't say it was normal, but what saved its ass was the fact that
Your
sample size is bigger than 30. Yeah. All right, so these 3 plus, there's 2 formulas for n. There's the formula if I'm talking about means, and there's the formula if I'm talking about percentages. And like always, you should probably double check these formulas with the ones listed in the book to make sure that you can read my writing. The biggest mistake people make on these is to forget to square that poor dude. Poor little dude. Another big mistake people make here is if I say 3%, that ain't 0.3. Shit. That's 30%. 3% is 0.03. All right, maybe. Yes?
Sorry, I just came back in. Is this for the formula sheet?
Yes. So that's chapter 8 in a nutshell. Chapter 9 really doesn't give any new formulas, but you can put down like this guy. No C shit. With this, remember this is what was on the board for that quiz we took. And this guy. Right? And then one last one is the new one. Become an N. By the way, I did this in my other stats class. 10.2 is extra credit. Section 10.2 is extra credit. You can do it or not.
You mean homework?
Section 10.2 homework is extra credit. There will be a bonus question on the test from Section 10.2 if you want to try those out. you don't want to try them out, go.
So just doing it gets you extra credit? Or do
Yes,
you have to
doing it and getting enough of it right gets you extra credit. Yes.
You need
10.2, yes. What about, oh, it's extra credit. What is 10.2? I don't know, third base. I think that's it. Anybody have a suggestion for something I missed? No, okay. Thought maybe I remembered it all. You never know.
E equals the z times sigma over this.
This is the error. This is the error. This is the error. We know that's true. Yeah. Okay. Anything else? Anybody? Any suggestions? Anything else? Okay. That's it. That's what could be on your formula sheet. You can bring in old formula sheets that you didn't lose credit on. Bring all your formula sheets in that you want to. Right? Okay. All right. So, what do you guys want to focus on? Yes, ma'am.
Can you do percentages, the 5-step percentages or whatever?
Yeah. Make sure I got all this stuff here. Yeah, cool. Are you blurry? All right, so there's a request to do a percentage hypothesis test. I'm gonna make one up real quick because I got the one on the practice test done already. Kind of put it over here while everybody catches up on that stuff. You're not working still, are you? No. You are. Oh. We feel the percentage of Rite Aids that already have you're not gonna work. Christmas decorations, Christmas stuff up is more than 75%. I don't know how you feel about, there's two types of people. The people that want Christmas to start in September and end in March. And people that, me, let's see, that makes it less special, let's keep it in December. So I don't know where you fall in that. Right. Oh, why? Anyway, really good. We feel that the percentage of Rite Aids, I love that. Rite Aids, right? Rite Aid, the percentage of them that already have Christmas stuff up is more than 75%. So test the claim. To test the claim, we sample 84 Rite Aids and find what, Jeff? I don't know, man. Shit. How do they do this one? So, yeah, okay. And find 67. Dude. Okay, that'll work. Let's see if that works. Sorry?
What's it like after 75%? You said something test the claim.
To test the claim.
Oh.
Yeah. Use alpha equal to 0.05. All right, so let's try this out. You guys try to do the first step, right? The claim and get the hypotheses set up.
sorry, that already have Christmas and what else?
That already have Christmas stuff up. So we feel that the percentage of these pharmacies that have Christmas stuff up already is more than 75%. We sample 84 and find 67 do. Use alpha. Not every word is important. So everybody got the formula sheet stuff? Yes, okay.
So the first step is to find it.
What's up?
First step is to find it.
Yep. So first step, what's the claim? B, good. Greater than?
0.75.
0.75, I love it. So where's that go?
The null will be greater than.
So where's that go?
Uh,
The high.
the height.
Why? Does not have an equal sign. I can actually show evidence for it. Doesn't have an equal sign, so it goes into the high. That's it. If it had an equal sign in it, it would go in the hub. So what is the null hypothesis?
He is less than or equal to.
Good. P is less than or equal to 0.75. So will this be a one or a two-tailed test? One tail. Because it's in one direction. I like it. How are we doing so far? Is everybody decent with that? You guys doing all right? Yeah. I ask that every now and again. Yeah. So you guys have that kind of zombie look. It's that time of year. Huh?
Is it that time of semester?
When is Thanksgiving? Jeez. Okay. What's the second step? See if it's normal so I can see if I can use these scores or not, right? What do I have to check here? Yeah, I gotta check NP and NQ. What's N?
84.
84. And what's P? 0.75. Kick ass. We're assuming that's P. So that's 3/4 of 84. And then 63? Yes? Four goes in 84, 21 times 3 is 63. Yes, I don't know. I'm going to stop asking. You're not okay. I'm going to answer that question myself. You're not doing fine. Did that make sense what I've done so far? N greater than 30 is if it was a test for what? A test about not a percentage, but about when would I use N greater than 30? If it was a test for a mean. If it's a test about a percentage, I've got to use the test that uses percentages.
You also don't use the, actually.
What about NQ? What's Q?
0.25.
Yeah, the rest of it, 0.25. Check. Yes. The only time that on a test I would allow that to happen is if I asked not a full hypothesis test. If I said something like, is this normally distributed and is this blah blah, you see what I'm saying? Because if I put a full hypothesis test where it wasn't greater than 5, and you didn't realize you didn't have to do it, you would waste time doing it, and that would be so evil. Right? So I'm not going to do that intentionally. So if you think it's not normal in a hypothesis test, you do it anyway. Because you either miss something or I miss something. I'm human. You can write down, I don't think it's normal, but whatever. Got your meds, Jeff. And then you just do it. Right? So what's that mean, what we just did? What's that mean? It's normal enough. So we can use z-scores. What if it wasn't normal enough? Can't do shit. Good. And again, I wouldn't do that. That'd be so evil. So I love this idea. The first step is, what the hell are you talking about? Second step is, why are you allowed to do this? Right? And then I start doing it. So that makes sense. What are we talking about? Why am I allowed to do it? Then I start to do it. The next step is I set up rejection region. I set up what far enough away is. Sorry. I always make that friend zone in my head, but it's not what it is. Not the friend zone. It's rejection region. So what did I tell you to help us figure out the rejection region? Alpha's 0.05. And we figured out two things. We can use z-scores, and it is a one-tailed test. So what is that z-score going to be?
$1.65.
1.645, yeah. Whoever said that. Good job. Where does it go? Is it positive, negative? Where's it go?
Is positive
Well, why? Yeah.
because the alternate is
Greater than. It's got to be up that way, right? H1 always sets up the rejection region, so you just see which way the arrow is pointing. If it said not equal to here, it would be a two-tailed test. Yeah. So to find evidence for greater than, I've got to freaking be greater than. That makes sense. And then down here I put 1.645. How do I say that in words? If Z star is greater than that, we can reject the hoe, support that. I like it. So if you make it into the region called the rejection region, we can reject the null. Yay. Go us. Sometimes math people get their names right. Alright, so now we've set up where evidence starts, so then we just go see our sample and see if it's enough evidence. So what do we know from the sample? What's p hat?
0.7976.
How'd you get that? Yeah, 67 divided by 84. 67 out of 84 right age. This crazy ass people. What is it again? Sorry. Who to what? 0.80. So it's like 0.7. 797. 6. Okay, so 0.80. Yeah. Well, 0.7976. So 0.798. Oh yes. Crazy ass Jeff. So again, just to remind you guys, you can make everything 4 places. Because that'll meet all the rules, except for z-scores, because you can only use 2 places. Yeah. So from the sample, what did we see? How many successes did we get in the sample? How many successes did we get? How many right aids did we look at? 84. And out of those, how many had Christmas stuff up? 67. So 67 out of 84. Yeah, so again, high schools are sucking at this. I don't know what it is. Or if you guys just miss that day all the time. I don't know. But percentages are so really misunderstood. They are always part out of whole. And that's why I just look at my sample. Out of 84, how many do we find? Oh, 67 out of 84. Bam! But I'll always get somebody to say p hat is 67. That is way bigger than 1. That is a problem. Holy shit. Is 67 out of 84. Now it makes sense. And that's all I need for my z-star formula. Z-star equals p hat minus p, what's p? 0.75. Divided by the square root. What goes in there? Good. And what's p and q? What's p and q? 75 and 25. Divided by 84. Yeah. Which way did I go wrong? 1.17.
1.15.
Hey, come on, that's really good. Come on.
1.015.
What is it?
1.015.
Shit. That's worse. Oh well, I tried. So you get 1.02? Okay. Real quick, I mean, wouldn't you say, if you just look at their p hat, it's almost 80%. That is bigger than 75%, right? But it wasn't bigger than it enough. It was only one step up. And that could happen naturally if the percentage really is 75. That is what a hypothesis test is. Not only does my sample have to actually look like it could work, it actually has to be so much bigger in this case that that's overwhelming evidence that it is bigger. But any sample I take, if 75% is the real percentage, any sample I take could be off from that just by pure chance. And is my sample very big? That was only 84. Holy shit, Gallup does 1,200 at least, just to cover their ass for this, you know. Okay, maybe. So what do we do here? Do we make it? We suck. We only got to about right there. So we say what here? Fail. We fail. We fail to understand. No, fail to reject the hoe. Oh gosh. Fail to support the high. That is not your conclusion. I haven't even started on the 5th step yet. That's just the little thing I can write immediately when I get that. Can somebody, so we got the answer ready. Here's the little extra step. Can somebody get the p-value for me? The value of p. How do you find the p-value? It's going to be the area and the tail that our z-score makes. So if you look up our z-score, you get that. 1 minus that, you get the p-value. Bless you. 0.1539. So if you look up 1.02, you should see 0.8461, right? You could do the shortcut if you know how it works. So the p-value here, I already forgot what it was. 1359? No, 1539. Okay. Is that p-value small? No. Like normally it has to be around 0.05 or smaller to be evidence. So let me remind you what this means. The p-value is the probability that we would get our sample if that is actually true. So that's a pretty high probability, to be honest. It would have to be like 5% or less to start to be unusual, to start to be evidence that it's such a small probability that that's true. That's what more likely is. That's not true. That's why I reject this. If I get really far away, if my p-value is really small, I can reject it.
What's like a rule of thumb that you would use to find what is too small or too big for the p-value?
Oh. The standard amount is 0.05, right? That's what alpha is. We should know this by now. The book, it says if I don't say, then alpha 0.05. That's the one that's most often used. But again, depending on what error is worse, I can control that by changing what alpha is. That's why alpha could be 0.01 in some cases, 0.005, 0.10.
So will it just be what alpha is in that problem, or always 0.05?
If it doesn't say, 0.05 is the standard one to use. And you've seen that in other places in the book. If they don't say, you use 0.05. Yeah. Because that's the most go-to one. Yeah. So, telling my other students I felt like I was in the dentist's office waiting room. Is that all right, you guys? So I want you to realize, if this was a test for a mean, it would have felt very much the same, right? We still have to write the conclusion, though. Can I take this away? I'm taking it away, so apparently. How do I write my conclusion? Which one was my claim? The ho or the high? The high. So I'm going to use this language right there. I'm going to use a language that talks about my claim, not the language that doesn't talk about my claim. There's no guessing. You don't have to guess, reject, or support. You never say accept. Never frickin' say accept. Because that implies proof, and this can never be proof. It can only be evidence. So we either reject the null or we fail to reject the null. So in this case, we have failed. So we have not found sufficient evidence to support the claim that what?
The right ad.
More than 75% of Rite Aids have Christmas stuff already. Yeah, become a word. There you go. Barf. Sorry, don't like writing all words. We have not found sufficient evidence to support the claim that more than 75% of Rite Aids have Christmas stuff on. And please, I understand as a student, you're just memorizing ways to say it so you can make Jeff happy. Whatever's going to make this guy happy, give me your grade. But if we didn't make it in here, then that's not evidence that it's more. That's what we're saying. We did not find evidence to say, to support that it is more because we didn't get far up enough. I mean, so the way that we say it matches with what the result should be, just visually. That's my hope. That's my hope. So that was a good suggestion. Anything else you guys want to look at? Yeah. Quiz 1. Oh, so not quiz 1. Okay. So, what was the problem? Yeah. So quiz 5. Yeah. Thank you. Which problem are you talking about?
The one.
Is that the one about how many voters must you survey?
Yeah.
Okay. So guys, how many blank must you survey? What letter does that represent? What variable would represent that? N. So on this level of just as a student, you read through the question is trying to tell you what it is we don't know. I mean, that's what a question does, right? Think back to algebra, you looked at the question to figure out what your variables were. Kind of makes sense. How many? Okay, I don't know N. Oh, I want a formula where N equals stuff, so I can figure out what the hell N is. You guys semi with me? So on that problem, we had already figured out what P hat and Q hat were. Whatever they, I'm just going to make something up. 0.61, 0.39, let's say. Right? And I say how many surveyed to be within 2% at, let's say, 99% confidence. So on that quiz, you had a confidence level you were working with. I'm not going to pick every one because there were different versions. I'm just going to say 99%. You had a P hat and Q hat that you calculated. So I'm just going to make up those. Right? And then I gave you an error I wanted you. Some of you guys had 3%, some of you guys had 2%, whatever. Right? So which formula am I going to use? Because I know I got to figure out N.
M equals A squared, B squared times P hat times Q hat over P squared.
Yeah, and you only use 0.5 here if you don't know what these are. But the problem right before this, you figured out what they were. So don't put 0.5s there. You know what they are. So in this case, I'm going to pretend like I had a version of the quiz where they were this. So what's the z-score for 99% confidence? Anybody know that or has to look it up? 2.576. It would be 575 if you got it from the z-score chart, right? And that's quaint. But that'll still work. I wouldn't take points off if you did it that way. What goes here? Keep going. That's z-squared. Everybody sees where that comes from?
Yeah.
What would make it different? Why would it, if I put a different number here, that would mean I would have to have a... Why did we put that number there? Because it goes with 99. If I said 98, it would have been 2.326. Blah, 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 blah. And now what goes next? 0.61. 0.39 divided by, what's the error that I want? 0.02. Kick ass.